Yes, but now we will test with first Bible um, outer almost uh, almost critical research on the novel progressive soccer and opportunities routine protocol technologies for enhancing network of performance for multimedia communication.
तुझे आवाज नहीं आई?
Play after CCTV.
कम्युनिकेशन वाला तेरा टॉपिक है. टॉपिक बोला वो अभी. हेलो तो सर.
Hello, good morning. Good morning to all of you.
Good morning.
Hello. Good morning.
Yeah, good morning to all of you. This is the session 5 of signal processing and network communication. So there will be 10 minutes duration for the presentation of your paper, and after the presentation is over, one best paper of the session will be evaluated.
Okay.
In case anyone want to ask any question, just either raise your hand or you can type your question given in the conversation. Nobody will be allowed to speak in between, and all of you are requested to put your mic off, to put your mic on mute. In case anyone asks to anything, you can type your question. In this session, Dr. Kuang and myself, we are the session chair.
Good morning. Good morning.
Good morning, Dr. Kuang. Good morning.
Yes. Yes. Good morning.
Yeah.
Okay. Our session about
Dr. Kuang, do we have the list of the authors? Do we have the sequence?
Now I can call some Bible our list first, second to my first present almost
I think Dr. Kuang, please type the name in the conversation box.
Yes. Yes.
Please type the name of the author in the conversation box.
Okay.
Who is going to present the paper?
I see. Abba sit review out Bible 3. First, Ames Opes. I don't see.
Yeah, please write the name.
Second.
Please write the name.
Yeah. Second, Tahasing Samira Diwa. Three, Abbas Siddiwi. Four, Kurum Latazan. Five, Asad Ahmad Khan Mohammed. Seven, Asid Manis Abu Ahas Cherukyu. Seven, Zakuma Bahil. I PS ra Z này Văn Thảo Lê Thàn Trương Đình Tú 11 Tân Nguyễn Văn Phương Nam Đào and Hồng Quang Nguyễn. Okay. first. I don't see. I don't
Hello.
see. I don't see. Ames up there. I don't see.
Nó giọng
Who? Yes. Second. I don't see first Bible.
Good morning and welcome everybody. With the aim to create a high academic forum for scientists as well as domestic and overseas experts on recent developments and future trends in intelligence and computing research, especially in the fields of electrical and electronics, mechatronics, and information technology. Today, June the 3rd, 2020, Toyomo University has the great honor of cooperating with Kalinga Institute of Industrial Technology, Odisha, India, to host the International Conference on Research in Intelligence and Computing and Engineering, RICE 2020. RICE 2020 is the fifth international conference, following the other four successful conferences in Nabur, India, March 2016, Uttarakhand, India, 2017, El Salvador in 2018, and Hanoi, Vietnam, 2019. The conference this time is being held online using Microsoft Teams application. In order to classify the knowledge as well as to have your own convenient gain a deeper insight into the fields mentioned, the conference is divided into 7 different sessions. Session 1, Smart Manufacturing Industry 4.0, chaired by Dr. Ji Hiu-le, Dr. Anh Mỹ Chu. Session 2, Deep Learning for Intelligent System, chaired by Dr. Bùi Thanh Hùng and Dr. Gravendra Kumar. Session 3, Artificial Intelligence and Machine Learning, chaired by Associate Professor Lê Tuấn Anh, Dr. Bruko Kishore Misra. Session 4, IoT Ecosystem and Application, chaired by Dr. Nguyễn Văn Tân, Dr. Sovik Pan. Session 5, Signal Processing and Network Communication, chaired by Dr. Nguyễn Hà Huy Cường, Dr. Rashmi Agrawal. Session 6, Advances in Modern AI and Healthcare Applications, chaired by Dr. Hoàng Mạnh Hà, Dr. Manju Kari. Session 7, Wireless Sensor Network and Applications, chaired by Dr. Hồ Đức Trung, Dr. Prasen Kumar Petnik. And now, welcome to our Session 5, Signal Processing and Network Communication, chaired by Dr. Nguyễn Hà Huy Cường and Dr. Rashmi Agrawal.
Thanks a lot for the introductory session. So we will be now proceeding with the first paper, Critical Research on the Novel Progressive Joker and Opportunistic Routing Protocol Technology for Enhancing the Network Performance for Multimedia Communication by Ahmed Obaid. Good morning, Dr. Solanki.
Hello, good morning everyone. How are you? So what's the waiting?
We are waiting for the first author,
Okay.
Mr. Ahmed.
Then do one thing, na. Meanwhile, time the Hyderabad team is ready. You try to take their presentation.
Yeah.
It will save the
Okay.
time.
Okay.
But
So
you
our
consult but you consult with your co-session chair who is
Yeah,
sitting.
he is ready. We are on the communication. We are in the communication.
You are in the time, no problem. Proceed. If they are ready, proceed. That's it.
Okay.
See, it will save the time.
Okay.
Please.
The second paper is genetic algorithm aided received signal strength maximization in NLOS visible light communication. Tahsin Samira.
Oh, Samira is there. Good morning, Samira. How are you? Samira is from Bangladesh, now in Korea. She is very good researcher.
Samira, can you unmute your mic? We cannot hear you. Can you unmute your mic, Samira?
Yeah. Am I audible now?
Yeah, perfect.
You are very much audible.
Yeah, good morning, Professor. Good morning, ma'am.
Good morning.
Yeah.
So nice to see you.
Yes.
Okay, so we will be starting the session with your presentation. So the time duration is only 10 minutes, so you have to keep and watch on that. And after that, a 2-minute question answer session will be there.
Okay. So
Dr. Nguyen? Yeah.
Shall I go for the first, ma'am?
Yeah, sure.
Okay, thank you. Good morning, professors. Good morning, everyone. So today I'm going to present my paper. I'm from Bangladesh. Recently, I'm working in South Korea. I'm a PhD student. So that paper title is Genetic Algorithm Aided Receive Signal Strength Maximization in Analog Visible Light Communications. So here, why actually we are going to propose this paper. The motivation behind this paper is like we are going to propose this paper in the scenario of VLC, and we are finding first I will go forward with the motivation of this paper, and the second one system diagram configuration. Then I will talk about the genetic algorithm, which is the key of my paper, the terminology of the genetic algorithm, how I did the power maximization technique, and lastly, I will conclude. So here I go for the motivation why we are proposing this paper, because in the VLC scenario, for the power maximization or the received signal index, there are two links, line of sight and non-line of sight. So in this non-line of sight link, actually there are various light intensity in the PD towards the PD. So we are proposing this present work, how we are receiving the maximum power power maximization technique in according to like genetic algorithm. So this is actually applicable for the indoor scenario in the VLC application. So then I will go for my system diagram configuration. So we are considering here the first of all LED transmitter in the transmitter side. So and the receiver side, it's like PD. So here if you see my diagram system configuration, we are setting the three coordinate A, B and C. So the first coordinate will determine the position of the PD, and the second coordinate B, it's determine the orientation of the P, how it's the PD should be rotate, and the third coordinates, it's coordinate C, that is defined as the arrival of angle, the incident light. So this is how my system diagram will act actually. So here if I see that how the LED it's working in the PD, there are I defined by alpha 1 and alpha 2. This is the angle between the normal line and how the reflection light is coming towards the PD. That is how my system diagram configuration. And later on, there are actually in the classes of search technique, there are so many techniques available, like simulated hill climbing. So I'm proposing in my VLC scenario genetic algorithm. So in genetic algorithm, it's basically a biological fundamental things. So it's developed by the John Holland in 1975. So it's fully a biological process. It's a kind of an evolutionary algorithm. And then there is like evolutionary cycle, which is like first it will select, actually the genetic algorithm means it will detect the survival of the fittest. From the various things, it will detect the best one. So the first one is selection and the second is modification. Then we will consider the evaluate the process, and the rest of the which is not the best we will discard then, and after that we will collect the best one. So in my paper, actually, GA terminology I defined as like here is organism, population, entity, chromosome, fitness, and ethylalism. So in this paper, actually, entity means we are maximizing the power. So in my case, power is the entity, and the chromosome is each number of population we are counting in the biological term, and fitness is it reflects the usefulness of the existing chromosome. And later on in this paper, actually, to while we are simulating, we choose the 100 generation to simulate this. And the power maximization technique, actually, why for this power maximization technique, we see that the concept behind this technique is the while in the VLC scenario there is so much light reflection, it's actually coming towards the PD from the different directions. So while we are using in the real scenario like microelectronics MEMS procedure, so it takes so much time to calculate the each angle. But when we apply the genetic algorithm, it will really optimize the best point from which angle I can get the maximized point. So that's why here genetic algorithm act will as an optimization algorithm and find the best direction which will ensure the best position in the analog scenario. And here I applied some power received equation, which is very common to in VLC scenario. And the flowchart of GM maximization, first we will assign some random generate some individuals, then we assign the fitness variable and choose the individual from that variable. Then there are in the genetic algorithm itself there are some procedure like crossover, mutation. So after crossing over this all procedure, finally we will terminate the other which is not the best position, that we will terminate and we will choose the best position for the indoor VLC. So in my result, actually, if we see we are actually generating the fitness evaluation over generation using GA and minimum fitness. So in my result over the generation, if we see that from the first generation to 100 generation, the reduction in fitness with the new generation it's occurring. And later on another result is showing the normalized signal power, received normalized signal power over the generation. So with the generation we can see that the angle we can identify from the which direction the maximum light is coming for the PD. So at the end what we will do, we will turn our PD towards the best position to get the maximum received signal for the user perspective. So actually what's the conclusion of this paper? We are proposing some novel technique which is useful for the maximization of received signal strength, and this proposed actually without, because in the VLC there is line of sight link and non-line of sight. So in this non-line of sight there are so many obstacles, but according to my proposed algorithm, it will help me to find the best position by when the scenario is analog scenario. So in future there are so many things we can consider, considering the reflection of number, coefficient, and other things we can add. So for this future indoor VLC scenario, this proposed algorithm will be beneficial. Thank you. Is there any question? Hello.
Anybody want to ask any question? Yes, Samira, it was a very nice presentation. There is one question from my side.
Yes,
that how you choose the fitness variable? Was there any?
Sorry, ma'am, it's disconnect. Can you tell me again?
Yeah. You explained that you choose some fitness variable.
Yes.
Using some randomization. So was there any criteria to choose that, or just randomly it was chosen?
Randomly, actually, I choose that variable. In terms of the the maximized power, I have to calculate. So I first in the for the generation, I select some random variable, and then from those variable, I calculate this.
Do we have any other method for that apart from the randomization?
Yes, actually, we applied here genetic algorithm, but we can propose like a particle swarm optimization, simulated inoculum. With that also we can propose and we can simulate.
Thank you.
Yeah.
Very nice. Dr.
Thank you,
Cuong,
ma'am.
any question from your side? Dr. Cuong? Dr. Cuong? Any question from your side? Any question from the audience? Okay, Samira, thank you very much.
Thank you so much, ma'am.
Most welcome. So the next presentation will be a 24 gigahertz wide tuning range CMOS digitally controlled oscillator for automotive radar by Abrar Siddiqui. Abrar? Yeah, can you hear me? Abrar, you are on mute. Please unmute yourself.
Hello. Is audible now?
I request everyone to please keep your mic on mute when the presenter is speaking. Okay. Yeah,
Hello,
Abrar,
madam.
please. Please continue.
I'm audible now? Okay. Good morning. Hello to professors. I am Abrar Sadiq. I'm from Pakistan and currently pursuing my PhD degree from South Korea, Cuong National University. And my research area is the RF circuit designing. Today I am going to present a paper topic 24 gigahertz wide tuning range, CMOS digitally controlled oscillator for automotive radar. The motivation of my paper is the design of 24 gigahertz CMOS oscillator for the automotive radar applications and digitally control as the tuning range. Automotive radar are very useful in the today's traffic for the collision.
Excuse me, Abrar, do you have the presentation slides?
Yes,
do
yes.
You have, yeah, can you share that also? Please share your screen.
Share PowerPoint. Files. They said have to share the files.
Hello? Hello? You see the button share near the mute button when you move the mouse. You see? How you see? At the button when you hover the mouse, it has a share that. Yeah, and you click this button and you see the PowerPoint and the button browse and you choose this button.
Excuse me, my screen is shared now. Hello?
Yes, Abrar. Yes.
No.
My screen is shared, right?
Yes, your screen is shared. Yes, we can see it.
Okay. Can you see my presentation now?
Yeah.
Slides?
Yes, we can see.
Okay. I will start again. I'm going to present a paper with the title "A 24 gigahertz wide tuning range CMOS digitally controlled oscillator for automotive radar." The motivation of my paper is to design a CMOS oscillator for automotive radar application and digitally control the tuning range of the oscillator. Automotive radar is a very important part of the nowadays in the automotive industry, because it senses the peak sensing, and it also detects the blind spot detections. And the our topic oscillator are very important part of the automotive radar, because it is the necessary part of the RF receiver and transmitter. So we have to digitally control the tuning range, because automotive radar work from the 23 gigahertz to almost 27 gigahertz. So we provide the digitally controlled of that frequency range, and not also we have to focus on the low power consumption and the other aspects of the oscillator, which is the phase noise, uh, low phase noise. Here in figure 1, present my proposed design. In the proposed design, I'm going to explain here my circuit. In proposed design, I normally use the currently used topology oscillator. There are so many other oscillator topologies, like complementary CMOS complementary CMOS and other topologies like the normal PMOS oscillator or NMOS oscillator. But I use the currently used topologies, which is M1. In this topology, two different transistors are used. One is the NMOS transistor, second one is the PMOS transistor. Here, transistor M1. Here, transistor M1 is the PMOS transistor, and transistor M2 is the NMOS transistor. These transistors are complementary to each other, and in the oscillator, there is the in the oscillator, there when the positive half cycle of my oscillation come, then the M1 transistor M1 will on, and when the negative half cycle of my oscillation come, then transistor M2 is on. So in this way, the half circuit will on in half cycle, and the other half circuit will on in the second half cycle. In this way, this topology benefits me in reducing the power consumption. So that's the one. That's the reason of using this topology, currently used topology, to decrease my power consumption. So, but if you see the diagram, circuit diagram, we're also using the transistor named M3 and M4. The reason of using this transistor is, while we're using the NMOS and PMOS transistor M1, M2 in currently used technology, topology, they suffer from the low transconductance. So to remove this con of this technology, we use transistor M3 and M4 to enhance the transconductance. The transconductance, what I'm asking is, transconductance is the necessary for the tank circuit to oscillate. The tank circuit, LC tank circuit, to oscillate, transconductance is necessary, because the inductor L1, which is formulated by the inductor L1 is for tank circuit. L1 have the different losses, resistive losses. To overcome resistive losses, we have to provide the negative resistance. Negative resistance is the transconductance. So to overcome this resistive losses, we provide also include the M3, M4, which give the negative resistance and overcome these tank losses, and the our oscillator will oscillate without any damping. So the other for the wide tuning range, we DCO tuning range, we provide two levels of tuning range. One is the fine tuning range, and one is the coarse tuning range. The fine tuning range is the, if you see, this is the 2-bit FTC, and CTC. FTC is the fine tuning capacitive bank, and CTC is the coarse tuning capacitive bank. CTC is the 3-bit coarse tuning capacitive bank, and FT is the 2-bit coarse tuning bank. So normally in the proposed in our DCO, the transistor M1, M2, like already I explained, in work in the currently used topology. M3 and M4 are the capacitive source degeneration negative resistance for it. The capacitive source degeneration negative resistance is the, if you see in the slide in our my circuit, the C3 is the capacitive source degeneration provided. So this C3 is used here to decrease the noise of the transistor M3 and M4. As I already explained, the main criteria is the low noise, low power consumption, and wide frequency range. So all this C3 will decrease our phase noise. So here for the wide tuning range, I already explained we use two cells, the coarse tuning cell and the fine tuning cell. Here, if you see in figure 2A, is this present the coarse tuning cell. Here the we use the metal, here we use the metal oxide capacitors, C4 and C3, along with the pull down transistors M5 and M6, while we also use the transistor M7, which we use a very low transistor width to decrease the on resistance. And for the fine tuning cell, we use the normal varactor based cells. Varactor is the like the voltage controlled capacitor, and we made this cell by using the transistors. Okay, each cell consists of two identical binary with metal oxide capacitor connected differentially by series and two pull down CMOS switches. I already explained. The sizes of the devices are already given here. If you can verify from here. The simulation results shown here is the wide tuning range for the fine tuning capacitive cell and the coarse tuning capacitive cell. In figure 3 shows the fine tuning capacitive cell tuning range. You can see that for with only 2 bits we can extend our tuning range from 23.8 gigahertz to 24.9 gigahertz. While in figure number 4, you can see that with the 3-bit coarse tuning capacitive cell, our frequency range increases from 23.8 gigahertz to 26.7 gigahertz, which are the required bandwidths required the tuning range of our automotive radar application. For next in figure number 5, you can see our output waveform of our oscillator. You can see that the output waveform is oscillate above and below the rail to rail voltages. This is happened because we also provide the capacitive feedback tuning in our oscillator. That's the reason our oscillation waveform is amplitude is increased. In figure number 6, we can show the simultaneous result of the phase noise of our DCO, which is a very good result at the 1 megahertz offset. We are getting only minus 104.4 dBc per hertz. In conclusion, we proposed a tuning mechanism, widening tuning range for the 24 gigahertz DCO for radar application in this paper. Our power consumption is less, which is only 721.5 microwatt with the voltage supply of only 0.9 volt. Our tuning range with the fine capacitive cell is the increase from 23.8 gigahertz to 24.6 gigahertz. And with the coarse tuning cell, our frequency range is 23.8 to 26.8, which is the required of our automotive radar application. So for our future work, we also can work on the other frequency band of the automotive radar application, as the automotive radar work on the two different frequency bands. One is the main is 24 gigahertz and second is the 77 gigahertz. So in our future work, we also see to accumulate the second 77 gigahertz band in our same circuit, so we can design a circuit for the multiple band frequencies. Thank you. Any questions?
Thank you, Abra. So, any
Hello,
question from the audience? Any question? Okay, Abra, one question from my side.
Yes.
Abra, am I audible?
Yes, madam.
Yeah. You talked about the fine tuning capacitive cell and the coarse tuning capacitive cell.
Yes.
So, are they both differentiable in some manner? Like
yes, madam.
in one scenario, one capacitive cell works better.
Madam, both are differentiated in terms of the frequency, how the frequency are changed with respect to our bits we provide. Like the coarse tuning bit is we giving the 3 bits. It's meaning if we give 1 bit, the frequency step changes more as compared to fine tuning capacitive cell. If we give 1 bit, 1 input bit, the frequency change is very less. So
Do they work same? If what are the other parameters which affect their performance?
Madam, they are work simultaneously at the same time they can work. Like first oscillator in RF transmitter, they are requirement of the our oscillator work with other circuits also. So with the passive, with the time passed, our RF circuits clock is lag behind from other circuit. So we have to tune our circuit so that our oscillator work with other circuit. So for this purpose, we provide the voltage or external bits to tune our frequency for oscillator frequency. So for this purpose, we provided 2 level of tuning. One is the coarse tuning, one is the fine tuning. One we provide 1 bit so that let's say as an example, we for 1 bit we get 500 megahertz step frequency increase step. And with the second, if we get only if we want more tuning of only 1 megahertz or only 2 megahertz, but our coarse tuning is provided with 1 step bit, we provide 500 megahertz. It cannot provide 1 megahertz tuning. So for fine tuning capacitive cell, it provides the 1 megahertz tuning also. So that's the both the difference between both these, madam. Sorry, madam, it's not audible. I didn't.
It was a very nice presentation.
Thank you, madam. Thank you.
Yeah.
Thank you.
Over to Dr. Cuong. Dr. Cuong. Dr. Cuong. Dr. Cuong, can you hear me? I request Dr. Nguyen to announce for the next presentation. Dr. Cuong, he might not be available. Okay, so our next presenter is Energy Efficient Cluster Head Selection for Wireless Sensor Network Using Fuzzy Logic by Kusum Lata Jain. Energy Efficient Cluster Head Selection for Wireless Sensor Network Using Fuzzy Logic by Kusum Lata Jain. Kusum Lata, is she present? Okay, she might not be here. Okay, so our next presenter is Importance of the Considering Bottleneck Intermediate Node During the Intrusion Detection in MANET by Arshad Ahmed Khan Mohabbat. Arshad Ahmed Khan. Is not also there. Jimada Shivaram, Lynn, Janvi Sandra, and Sai Kiran.
Yeah, ma'am, we are here.
Yes. Yeah, okay, you are present. Okay, fine.
Good morning, ma'am.
Yeah, so the next presentation is Analysis of Ransomware, Methodologies used by attackers, and Mitigation Techniques. Please start the presentation.
Good morning to all the professors and all the students present here. This is Shivaram from India with my co-authors Jahnavi and Sai Kiran. On behalf of my team, I would like to thank the chair of this session and committee members and team of RISE 2020 for giving us this opportunity even in the crisis of COVID. So the paper title consists of Analysis of Ransomware, Methodologies Used by Attackers and Mitigation Techniques. The abstract briefs what exactly ransomware is. Ransomware is a combination of two words, ransom and malware. Ransomware is a malware which gets installed in a person's computer without their knowledge. The presentation gives an idea about what is ransomware, types and techniques which attackers use to perform this action. So what if suddenly you cannot access your own files on your laptop or computer anymore? Well, that is what ransomware does. As the world evolved, everything is digitalized. So everyone stores their personal or work-related data on their computers. This itself gives a big chance to hackers to inject ransomware. Ransomware is more dangerous than phishing, where in phishing, it tricks users into performing tasks such as opening mails, wherein ransomware, it stealthily performs encryption to all the files on the machine once the malicious file is opened. This just sums up an idea of what ransomware is. My co-author Sai Kiran will continue further.
Good morning, everyone. So I'll be continuing about the categories of ransomware. So there are two major categories of ransomware, locker ransomware and crypto ransomware. Locker ransomware, also known as computer locker, which restricts the access to computer resources. It locks the interface and demands the customer to pay a certain amount. While a system is locked, the client can only interact with the screen shown by the attacker, in which the mouse is disabled and only few keys on the keyboard, such as numeric keys, are enabled to enter the amount, and then the computer is restored back to the original state once the amount is paid. So I'd like to explain one of the example of locker ransomware is Reveton ransomware. It came into sight by the end of 2012. It locks a computer by restricting their access, stating a message claiming that they are from FBI or National Police Force. where the user said that he was caught up in illicit activity and demanded to pay a certain amount to avoid further activities. So the next type of ransomware is crypto ransomware. This kind of ransomware finds and encrypts the crucial data stored in the computer and makes them inutile until the user obtains the decryption key, therefore also known as data lock. As we are evolved, everything has digitalized and all the important data is being stored on the personal computers and devices. The users tend to not have any backup for their data and hard disk failures, having a huge impact and giving a chance for the attackers to encrypt the data. So I would like to explain this image. So this image depicts what happens when a system is attacked by ransomware. It states what exactly happens to your computer and how you can recover them. To the left, it shows the deadline set up by the hacker to pay the amount, and the box in the right bottom shows the address where the user has to send the ransom. As we know that Bitcoin is a virtual currency and it do not have any physical form, making it impossible to trace the owner. So next will be continued by co-author Janvi. Shiva.
Actually, I'll take the methods used by attackers. So below are the methods used by attackers. They are malvertising, emails, and mobile phones. Coming to malvertising. Malvertising is also known as malware advertisements. Some pop-ups or advertisements may appear on your screen which direct to another screen, showing a message that your system is locked or your mobile phone or anything it could be. So the second one is the emails. Someone can receive an email from a company or a person whom they don't know, which tells them the victim to enable macros providing a gateway, and once they open that, they become the victim of the ransomware. The third one is the mobile phones. As most of the world's population are Android users, it is a great target to hackers to attack them, as they won't have any mobile security products leading for a message to appear screen indicating that Bitcoin is the only way to avoid loss of the data. I request Jahnavi to take the mitigation techniques.
So good day, everyone. This is Janvi, and as we have seen the methods used by hackers, we can prevent such scenarios by using mitigation techniques such as timed chat room links, where it is always estimated that 96% of the malware attacks emanate through these links. To avoid these, the employees must be made aware. Malvertising. As already explained what malvertising is, this can be avoided by not accessing to suspicious links and images. Backup of data. The primary goal of ransomware attackers is to halt the access of users to access their data. So this can be avoided by having a good backup of your data. Security tools and antiviruses. Having good security tools such as Norton and Kaspersky, which gives us a stable firewall and always upgrades the system with software, helps us to prevent such ransomware attacks. And this flowchart depicts what happens where a system is attacked by ransomware and the user does not have the backup with them. If the ransomware is detected on a system, we can check whether the backup or the data or in the system is encrypted or not, which is mostly the situation. If there is no need, then there is no need to pay the ransom, or else we check for an offline backup of our data. And if that is not present, you check whether the data that is encrypted is significant or vital to you. If the data is significant and vital to you, you end up paying the ransom amount. Or if not, you can have the backup of it manually or by any other sources. Now, this will be continued by Saikiran by explaining the adverse effects.
As we have seen, the methods used by attackers and the evolution of ransomware is gradually increasing. The payment requests are gradually increasing. If you look up on mid-2000, the amount was around $300. Now it is averaging for about $500. And usually the due date or deadline is set up for the installment. If the payment is overdue, the amount will be doubled or the documents are uplifted. As ransomware is transforming, it has increased by 90% last year. So it can be further be avoided by using various techniques, which will be continued by co-author Janvi.
So this bar graph depicts the damage caused by ransomware annually for over past 5 years. If you look upon a scenario in the year 2018, in the month of February, the Colorado Department of Transportation was attacked by SEM ransomware, where they encrypted over 2,000 PCs, network devices, and servers. These were only decrypted when they paid a ransom of $1.5 million. In another scenario, in 2019, a ransomware named Nemty ransomware came into existence, which was operated by an underground cyber criminals where they offered ransomware as a service, wherein the person has to sign up and was granted access to a web portal where he would create customized versions of these. another attack in May 12th, 2017, which is known to be a massive ransomware attack of the decade, has occurred, which is WannaCry. WannaCry is a self-propagating ransomware which exploited the public internet by making the Microsoft message server block vulnerable, where over 150 computers and 200,000 computers 150 across 150 companies, over 200,000 computers were held hostages. WannaCry is made up of two distinct parts, where one offers the ransomware performance and the other which is used for transmission. This malware propagates through a code called as Eternal Blue, which was created by shadow brokers. This situation was so severe that it was halted for many days, where Microsoft tried to kill the situation, which they failed to do so, and in turn they paid a huge ransom, which led to the creation of United States nation security, as much of the private information was put on stake. As we have seen how deleterious ransomware could be, I would like to quote that prevention has always been a better situation than the cure. So we can prevent this by having a good backup of data and having some system software which would provide a stable firewall and ensure the security system is updated. We have to make sure that there is no personal information is given while replying to emails or receiving calls where the caller information is hidden. It is also not advisable to scan documents and filter them on mail servers. Therefore, I would like to conclude by saying that by taking some certain measures, we can avoid from being the victims of ransomware. I would like to thank the chair, the RISE committee, and all of them who played their part on making this event successful and for providing us this opportunity. And we even thank all the students for listening to our presentation patiently. We would like to answer the questions if there are any. Thank you.
Any questions? Any questions? Thank you, Shivraman. And
yes, sir. We can hear you.
I have one question. This is your first paper which is going in the Springer. And I want to know what is your future plan, like how you are going to work out
any future applications or techniques in it?
Sir?
My question is, this is the first paper you have submitted in the BTech. What is your program in the future? Like, are you planning some practical work over there, or just want to come up with this?
So we actually want to make people aware with this paper, sir, because the minute details matter. We might accidentally click to some link without. Ma'am? Pardon me?
Yeah.
Given what is ransomware and how it is planning the attacks and how the phishing is happening.
Yes, ma'am.
So, do you think in future techniques may be developed to avoid it?
Yes, ma'am. There might be
any future for computing in it.
Yes, ma'am. As there are many antivirus which we have seen, for example, Norton and Kaspersky is there for now. If we have a good antivirus which will make our firewall more stable, these situations can be avoided.
Fine. Good.
Any questions? Okay, thank you very much, Shivraman and the team. And
thank you.
We'll invite our next presenters. Our next presenters are improved Doppler radar target detection method using quad code sequence generation by Rajkumar Bure.
No. He is Razi Bihag from Coimbatore. He is not Rajkumar, madam.
Raj?
No. He is next. I think. Yeah. Hello, Rajiv. How are you? Rashmi, madam.
Yes.
Madam, he is the Razi Vihag from the Amrita Vidyapeetham.
Sir, actually, I'm attending the conference. My time slot is 9:15.
No problem. We give you chance. Don't worry.
Yeah, then it's okay. Fine,
No
fine.
problem. Please, please, please.
Because the name is Rajkumar D.
Yes,
Bhule.
yes,
Is it the
yes.
same person?
Madam, if he is absent,
Okay,
you
okay,
mark
I got your
absent.
point.
Yeah, and give
Okay.
to next. Yeah, yeah, yeah.
Okay, fine. So we will continue with the Bihag Raji, and
Yes.
the topic is functional encryption of floating point ALU using weighted logic locking for enhanced security.
Yeah,
Yes.
yes,
So
ma'am.
Rajiv, over to you, Rajiv.
Thank you, ma'am. Ma'am, hello.
Yes, please start the presentation.
Sir, ma'am, is my slides visible?
Yes, these are visible.
Yeah, okay. So my title is Functional Encryption of Floating Point ALU using Weighted Logic Locking for Enhanced Security. Hello.
Yes, Rajiv, you are audible. Please go
Okay,
ahead.
okay, ma'am.
Yeah, yeah.
So this is abstract. Actually, floating point ALU is used for performing various fundamental operations along with the shifting and rotating operations. Since floating point numbers can represent both small and large numbers in the same way, it is preferred over the other ALU subsystems. Also, floating point ALU number system has high accuracy and high resolution. Also, it has high speed compared to other number systems. So the floating point number systems are usually employed in small and large numbers. And the encryption basic, our objective is to encrypt the floating point ALU architecture to prevent the unauthorized usages and to prevent the piracy issues. So the encryption technique used for uh, the floating point ALU subsystem is weighted logic locking, as it enhances the security. So we basically employ the fault impact analysis, and the weighted logic locking block is placed on the floating point ALU circuit by determining the nets with the maximum fault impact. And the results show that there is no significant increase in the area and power overheads for the encrypted circuit from the floating point ALU subsystem. So this is the introduction. So what we have chosen is the floating point number system, which has got single precision according to the IEEE 754 format, and it has basically three fields, namely the sign bit, sign field, exponent, and mantissa. The sign field is basically having 1 bit, exponent has 8 bits, and the mantissa part has 23 bits. So the single precision floating point ALU has the important modules, which are the exponent difference module, the right shifter, two's complement adder, leading one detector, left shifter, and the rounding module. Weighted logic locking is used to increase the Hamming distance against the key sensitization attacks. The fault analysis based logic locking reduces the high execution time for placing the keys. So basically in weighted logic locking, we have a control gate as well as a key gate. So the propagation of random key bit through the control gate happens when the other key bits are controlled. And when the floating point ALU subsystem is encrypted using the weighted logic locking encryption standard, the optimization of the area and power overheads are obtained. And the weighted logic locking encryption block usually increases the output corruption, and it has been measured using the Hamming distance for different combination of key bits. And the area and power overheads are validated. So this is the flowchart of the single precision floating point ALU. First, we have the two operands, which we basically labeled as N1 and M2. So the second step is to denormalize the two operands. So while denormalizing, we set the implicit bit to 0 or 1. So if we have set the implicit bit to 1, the Mandisa field will be expanded by 1 bit. So it will be basically 24 bits. But here we have set the implicit bit to 0. So we have Mandisa part as 23 bits. And the next step is to separate the exponents of the two numbers and compare the exponents. If the exponent of the first operand is less than the exponent of the second number, then we swap the two operands, and the fractional part is being shifted by following the condition d equal to modulus of e1 minus e2, which is the absolute difference. So now the fractional part of the second operand becomes a fractional part of first, and vice versa. So the next part is to do the 8-bit subtraction. Here we usually do the subtraction of the Mandisa part. F1 and F2 represents the Mandisa part of the first and second operands respectively. So if we are doing the 8-bit subtraction, we usually do it by the 2's complement method. And if we are not doing the subtraction, it's basically using the 1's complement method. And if the value is negative, we pass on to the values to the values of the Mandisa to the leading one detector. Then we normalize the values, Mandisa values. Then we approximate the values, and after the adjustment, we do it for the rounding process, and we obtain the registered outputs for both the exponent and Mandisa and combine to get the result. So this is the workflow of the proposed architecture. So our single precision floating point adder has the following modules as I have explained. We have the exponent difference module, right shift shifter, 2's complement adder, leading one detector, left shift shifter, and rounding module. And we synthesize the 32-bit floating point ALU, single precision 32-bit floating point ALU. And for the floating point ALU, we identify the node with the maximum fault impact. The fault impact analysis is performed using the HOPE simulator. And in the node with the maximum fault impact, we insert the weighted logic logging encryption block. And after that, we do the further area power analysis. And after that, we analyze the waveforms for the encryption strategy. So this is a proposed architecture. Here we have indicated the sign field, exponent field, and Mandisa field for the two operands. And first step is to calculate the, as I have explained in the flowchart, first step is to calculate the exponent difference. Exponent is basically 8 bits. And after calculating the exponent difference, we do the right shifting process. Here the exponent difference absolute value is 3. So we basically do the right shifting of the operand which has the less exponent value by 3 bits. Hence the 24 bits has been converted to 27 bits. And hence after that we do the 2's complement subtraction method. And after doing the complementation, we pass it on to the leading one detector. The leading one detector actually detects the first leading one, and it left shifts the corresponding output by the number of zeros preceding the leading one. And after that, we do the normalization process. It is converted to 26 bits, and after rounding, we generate the required Mandisa field as per the IEEE 754 standard, which is 23 bits. And also the exponent, the weighted logic locking encryption module is inserted in the subtraction module. And after that, we obtain the exponent output as 8 bits. So this is the illustration how a weighted logic locking encryption block works. So we have chosen for reference, we have chosen a C70 benchmark circuit. It has basically got 5 inputs and 2 outputs. So we have inserted a weighted logic locking encryption block, which has got a control gate and a key gate. 2 input bubble NAND gate forms a control gate, and a 2 input XOR gate forms the key gate. The net for the C17 benchmark circuit, which has a maximum fault impact, is identified as net number 16. And in the net number 16, we have inserted the key gate. These are the truth tables for the benchmark circuit encrypted using the weighted logic locking block. And we have the inputs and we have the outputs. And the output of the benchmark circuit and the output of the encrypted benchmark circuit have been represented. So we have inserted a key bit combination for a bit size of 2. Hence we have 4 configurations. So 0, 0, 0, 1, 1, 0, and 1, 1. So what we can observe is that for the key bit combination 0, 0, the output of the benchmark circuit without insertion of the key bits and the output of the encrypted circuit after insertion of the key bits is found to be same for the key bit combination 0, 0 alone, which means that it generates 0 output correction. For all the other combinations, we can see that output of the encrypted circuit and the output of the benchmark circuit differs by 1 bit. which means that Hamming distance of 50% is achieved. So these are the power profile and the area profile for the proposed architecture. We have indicated the encrypted floating point ALU and the floating point ALU, both area and power profiles. And what we can observe is that the total area of the encrypted floating point ALU is increased by just 2.67% compared to the floating point ALU, which means that if we insert the weighted logic locking encryption block to the floating point ALU, the area just increases by 2.67%, which means that it is optimized and it has not got much increase in the area, so it can be applied to the weighted logic locking encryption block can be inserted to other modules as well. Similarly, we can observe for the power profile for the all the parameters of power, cell internal power, net switching power, total dynamic power, and cell leakage power. Once the weighted logic locking block is inserted into the floating point LU, there is only a small increase in the percentage of power, which is also which also proves the fact that weighted logic locking encryption block is a good standard for encryption methods. So these are the simulation results. So we have used different combinations of key bit. Like we have first diagram shows the key bit combination as 0 0, and the last diagram shows the key bit combination of 1 1. For the two inputs which I have chosen as the 32-bit inputs, I'm able to obtain the correct outputs for the two key bit combinations which are 0 0 and 1 1. For the other two key bit combinations 0 1 and 1 0.
Yeah, Rajiv, there may be some problem in your network.
Ma'am, you were not able to hear what I explained till now. Hello?
No, it was clear to me. Just last from 1 minute, I was not able to hear.
Now is it okay?
Yeah, it is okay now.
Should I explain the 7th slide or I mean?
No, this is okay. This is self-explanatory. I can see it. No problem.
I'll explain this one. Waveforms I'll explain.
Yes.
Yeah. So for the key bit combination 0 0 and 1 1. The correct those forms the correct key bit combinations, and for the 32-bit inputs which I have given, the correct outputs have been obtained for these two key bit combinations which are 0 0 and 1 1, and hence they forms a zero output corruption. But for the other two key bit combinations 0 1 and 1 0, a Hamming distance of 93.75% is obtained, which has been already proven. This is a conclusion. So a 32-bit single precision floating point ALU subsystem has been designed using a weighted logic locking method, and the metric fault impact is employed to determine the location of key gate insertion to protect the subsystem. And the insertion of the weighted logic locking encryption block at the node with the maximum fault impact is done to increase the output corruption. The functional waveforms for different key bit combinations is obtained, and the output corruption is determined using the Hamming distance. The encrypted floating point ALU works correctly for the key bit combination. As I have explained, K1, K2 is 0, 0 and 1, 1, and incorrectly for the other two key bit combinations. The secured single precision floating point ALU subsystem consumes relatively less area and power compared to the floating point ALU. And future work involves evaluating the security metrics for the system by expanding the key bit size of the encryption scheme. So these are the references which I have used. Thank you. Ma'am, hello.
Thank you, Rajiv, for such a nice presentation.
Thanks, ma'am.
Yeah. Any questions from the attendees? Any questions from the attendees? Okay, Rajiv, I have a small question for you. Why C17 benchmark circuit was chosen in your study? Why you have chosen the C17 benchmark circuit?
Ma'am, actually, I have chosen it for just illustration of the weighted logic locking encryption block. Like actually, I have applied to the floating point ALU subsystem. Used the encryption weighted logic locking block for the floating point ALU subsystem. For just the illustration, I have used how the control gate and key gate is working. To just illustrate that, I have used the C17 benchmark circuit. That's all.
Thank you very much.
Thank
It
you.
was a nice session. Yeah.
Thank you. Thank you.
So we have the time for our next presentation. Our next presenter is detection of DOS, DDoS attacks in software-defined networking by Trong Din 2. Mr. Trong, are you here? The next presenters, Phuong Nam Deo and Hong Quang Nguyen. Phuong Nam Deo, are they present? Next presenters, Dang Trung Than. Yes, here present. Dang Trung. Application of microstation and TK tool in assessing the current status and the change of agricultural land in Ban Cat town from 2014 to 2019 by Dang Trung Than.
Hello.
Yeah.
Hello. Sorry,
Yes.
sorry, doctor. My is not already now. I win representation after 15 minutes. 15 minutes. And the last session.
Yeah, actually this is the last presentation. Yes, doctor.
Thank you, sir. Thank you.
Okay, we'll just wait for 5 minutes and then we'll continue with the other presentations.
chia sẻ cái quyền.
Em chia sẻ. Dạ.
Em nghe.
Dạ xong rồi hả?
Bây giờ share cái slide đó lên.
Chia sẻ màn hình.
Sao nó lại out rồi ta?
Đó nó đang chiếu ở đây. Dạ,
nghe rồi.
Are you ready to present? Hand.
Trình bày hả?
Hai xem mọi người đến hello.
Hello everybody.
Yeah, hello.
Yes. Today I would like to present the topics of application of microstation and TK tools in assessing the current status and the change of agricultural lands in Bến Cát Town from 2014 to 2019. I would like to bring this research to the prize conference because I would like to produce the importance of computing and technologies in ruralities. It can apply in many areas, especially in the areas of agriculture management. This study is carried out by Đặng Trung Thành, Nguyễn Huỳnh Ánh Tuyết, Võ Quang Minh, Phạm Thanh Vũ from Thủ Dầu Một University, Cần Thơ University of Vietnam. Our presentation includes 4 parts. The first is the introduction. The second is the research methods. The third is the result and discussion, and the finally is conclusion. Introduction. Bến Cát Town is one of 9 administrative units in Bình Dương province. It's about 40 kilometers from Ho Chi Minh City. Includes 5 wards and 3 communes. Bến Cát has the agricultural land area of over 60%, and this rate is changing every year, together with the development of the area. Cái screen này dễ hơn nè, cái này chia sẻ dễ hơn. Yes, so sorry for this inconvenience. The assessing these trends in agricultural lands is a mandatory duty because it has an important role for the local authority to how the mitigation methods and to make plans for the future. The application of technologies in making maps and statistics changes has been used all over the world and in Vietnam. Since the development of geography information system, especially the development of many types of software to support. Without the help of technology, this duty is extremely huge and hard to do accurately. Microstation and TK tools is a specialized software and tool for land management in Vietnam. They help to manage spatial and attribute data and statistics the attribute data quickly and accurately, so enhance the efficiencies in terms of time, effort, and cost. Therefore, our research was conducted to assess the change of agricultural land in Bến Cát Town using microstation and TK tools. Next, we would like to move to the research methods. In this research, we used 4 main methods. The first one is the statistics method. This method is used to statistic the number of established and implemented new projects of our organizations or individual households and change in types of agricultural lands each year. The second method is the geography information system. This is used to update and correct the change in agricultural land new maps due to the implementing new projects. The data we use in this method is the land use maps in 2014 and the annual data on land use trends from 2015 to 2019. And the software we use in this method is the MicroStation and TK tool. The third method is the field investigation. This is a very important method we use to check the land use trends in reality and to record and make the new plans in 2019 from the old land use map of 2014. And the final method is the aggregate data. This method is used to aggregate the data of commune level from the to make the district level data from the commune level data. And next is the third part of results and discussion. According to the statistics, the number of work and projects approved in the annual plans in the 5 years from 2015 to 2019 is 473, but the number of projects implemented is just about 134. So the area of agriculture plan decreased by implementing the projects is about 137 hectares, and the total area of agriculture plant decreased by changing into households is about 85 hectares. So the total area of decreased agricultural lands in the area from 5 years is 222 hectares. From the statistic data, we conduct the field survey to check the trends of the land use types in reality and to make the change in the attribute data of the 2014 map to make the new map in 2019. By making this map, it's easy for us to realize the distributions and the scale of each type of agriculture plan. For example, in this map, in the first map, we can see the light orange color. It means this is the distribution of parental crops, and this areas has been decreased into many new projects, new industrial zones in the 2019. So it decrease of annual growth a decrease in the 2019, and the yellow colors area is the rice crops. This kind of plant yield is also decreased in the map of 2019 because many area have been changed into other kinds of land use. Many other kinds of land use, for example, lands for forest and aquaculture in very little in the maps. Based on the results of this map, we use TK tool to export the data of the area of the change in area of each type of land use type. Agriculture plant is divided into 6 types, including lands for planting rice, lands for planting other annual crops, land for planting perennial crop, forest lands, lands for agriculture and other agriculture land. The total agriculture areas in 2019 is about 14,002 278 hectare. It decreased about 222 hectare in comparison to this area in 2014. This decreasing accounting for about 1% in 5 years. In these types of agricultural lands, the areas of the land for planting perennial crops has much decrease in comparison to other types, because this land much of these kinds of plants have been turned into non-agricultural land to build industrial zones or households. By using TK tools, it is very easy for us to make to statistic these chains of agriculture, and it makes to the inventory of plants be more easier and faster. Finally, I would like to have a conclusion. The application of microstation software in assessing land use change is where the TK tools in exploiting statistic data have enhanced the convenience, the rapidity, and accuracy in monitoring the change of land use types. The study result has contributed particularly in using digital maps to support the land inventory in the year 2019 and showed clearly the trend of urbanization and industrialization in Bến Cát town during the last 5 years. And it also produced the importance of intelligent and computing technologies in many areas, especially in the area of land management. That's all for presentation. Thank you very much for your listening. If you have any questions, please feel free to ask me for more detail. Hello?
Any questions?
Yes.
Anyone want to ask questions?
Yes, you have a question?
Thank you, Tam. It was a very nice presentation.
Yeah.
So why you have chosen that TK tool? Are there any other tools available? You have chosen the TK tool in analyzing this.
Yeah.
Are there other tools available? TK tool, yes.
I use the microstation software and TK tool. This tool is used to have to support this software.
Are there other tools available? Any other tool apart from this?
Yes, I just use this TK tool.
Okay, so
yeah,
the lot of transformation is going in the agriculture land. A lot of transformation is going in the agriculture land. So what do you think? What are the reasons behind it? Their transformation.
Can you repeat your questions? Sorry. Can you repeat your question?
have typed my question. Than, you can read it.
Đi đọc.
Bên tin nhắn con.
Am I audible?
Sorry,
What
please,
factors are responsible for transformation of agricultural land?
Nhân tố nào ảnh hưởng đến việc chuyển đổi đất nông nghiệp anh?
Yếu tố nào do
kinh tế,
yếu tố kinh tế xã hội phát triển các cái cơ sở hạ tầng.
Yes, the factors are responsible for the transformation of agricultural lands is that the development of the economy and society. Bến Cát, located in Bình Dương province, is an industrial province in Vietnam. There are many industrial zones established in this area, so the change of agricultural land into industrial lands very quickly in recent years. Most of agricultural land is changed into the non-agricultural land to build house or to make industrial zones.
Okay. So,
Yes.
and you have chosen the study from 2014 to 2019, 2014 to 2019. Any specific reason for 5 years data?
Có yếu tố nào nữa không? Ngoài yếu tố của kinh tế xã hội.
Chủ yếu là yếu tố kinh tế xã hội.
In this area, the main major is the development of economies and society.
Gọi mình ấy, đây section mấy đây?
Cái từ ấn vào đây sẽ là chung của cái màn hình này mình
Đây.
Section 3.
Section 3.
I'll write my question.
Đức. Section 3 là bài Đức.
Đây mình vẫn ở section 3.
Section 3 mà.
Cái này nó gọi xong đây làm gì?
Chắc là nó chuẩn bị đến mình thì chắc nó gọi thôi.
Thế bài này là mình phải
từ năm này đến năm này.
Là 5 năm thống kê theo cái
In Vietnam, according to the current regulations, we have to inventory the land use change in the period of 5 years. It is a mandatory duty of area authorities to manage the land resource.
Hello.
Hello.
No. Hello?
Hello?
Can you hear me?
Yes.
Okay. Thank you.
Mất tiếng rồi.
Đặt quyền bên em đi. Quyền bên em. Rồi bây giờ mới cho này.
Là sao vậy? Tức
là phải trình xong rồi nhưng mà đợi con thì xong rồi tắt cam cô
tắt nè.
tắt cam.
Hello everyone.
Hello.
Hello.
Yes.
Hello everyone. Can you hear me?
Yeah, I can hear.
Okay, let's start.
Yeah. Just give me 2 minutes and we'll start.
Yeah. Hello everyone. Today I'm present about the network attack detection in the SDN system. My presentation consists of 4 steps. Introduction to the software-defined networking methods for detecting the nano-service and distributed the nano-service attack and experiment and simulation and finally constellation and introduction in a traditional network address control the data plane and control plane upon some physical device. It's bring bus mutation and configuration for the each device and enable accurately monitor network traffic and easily to be started to and depend on the vendor from about limitation SDN were bonds. SDN technology that separates the control plane and data plane from the network device. But beside the issue of handling traffic to the data plane, partition is a problem to solve it. Some of our problems resolution method consists of two sides and this is machine learning and statistical analysis. In this case, I use the entropy. In this case, I use entropy to the detection denial of service, and distributed service attack. And to be easy to miss through the randomness of implement appearing in the dataset. Um, the management of the entropy in the central range. Cinema.
Please,
Hello?
please turn your camera on.
Hello?
Yeah, please turn your camera on.
Can you hear me? Hello?
A camera.
Camera?
Yes. Your pic, photo. Your
Okay.
video.
We we are using the entropy to YouTube mix so the randomness of element appearing in the dataset. The monument of entropy in the central range synonymous with the property of the occurrence of the world value. Entropy define the formula first. E in the dataset, the long numbers package arrive in the system. Second, we second I computed the probability of the probability of the baskets bring in the dataset, and finally I computed the entropy in the total probability on the item in datasets. In the datasets, my experiment consists to two phase. First, I computed the entropy of the 5,000 buckets, which were 4,000 buckets, which were divided into into 20 attack. In the E attack, I use to 20 buckets for experiment. After commuting entropy of phase one, due to the 195 is the threshold for this phase. Second, phase two, square five more. Square phase one as a phase high. I increase the total basket count and number of the attack for increase the reliability of the threshold compared to the phase one. we are using the 0 by 1 0 by 1 to 4 as threshold for phase 2. My spherical model consists to three partition stack network ISB and SDN network. As as shown in the figure of the normal traffic, the entropy range from one zero zero to 04 to 0019. Beside beside us, the artist traffic has both out of the range less than threshold of the phase 2. Um, and this side we can use it to for the detection solution. We are using the entropy to calculate the tremendous level of the packet size go up simulation attack and our data collection we are collected to the natural business model number way. Uh, we can also classify the asset into types and provide the asset information as a permission for the next brain step. Thank you for listening. Any question?
Thank you, Dan.
Thank
Do you
you.
see any future scope of your work?
Uh, uh, your future scope. I using the another method to for detection attack network, and I comparing the kind of the kind the machine learning methods. Yeah.
Thank you very much.
Thank you.
Thank you, Dan. Thank you.
Thank you. Hello thầy. Hello.
Yes, Nikhil. Nikhil. Nikhil, you want to ask anything? Okay, so the next presenter is Mr. Nikhil Gupta. The title is Importance of the Considering Bottleneck Intermediate Node During the Intrusion Detection in MANET. Yes, please start. Nikhil, you are not audible. Please unmute your mic. You are not audible.
Hello? Hello, can you hear me now, ma'am?
Yeah, yes, now I can hear you. Nikhil, you are not audible again. Nikhil? Yes, Nikhil. I think there is some problem with your speakers. You are not audible at all. Can you please type in the chat box?
Hello, ma'am. Am I audible now? Hello.
Yes, you are audible.
Okay, ma'am. For the convenience, ma'am.
Yeah, it's okay. Now please start.
Are you able to see my screen, ma'am?
I am not able to see your screen, but you are audible.
Okay, ma'am. Screen. Switch. To share the screen. Okay.
Click on share and click on desktop. Then you will be able to share.
Ma'am, I have connected through mobile, ma'am.
Yeah, in mobile also you can do. You will.
Yeah, I got it.
Okay.
Yeah. Sure. Yes. Are you able to see the screen now, ma'am?
Yeah. Yes. Now I can see. You are audible also, and I can see your.
Sorry, ma'am. I'm starting now. So, first of all, my topic is, first of all, I want to give you a thanking opportunity to all the members of this organization for giving me an opportunity to, in this COVID-19, also you are conducting this event, in this event, and you are making us to overcome our knowledge and give away. My topic is importance of considering bottleneck intermediate node during the intrusion detection in manner. I am the co-author Nikhil Gupta, and my guide is Dr. Arshad Ahmed Khan Mohammad, Assistant Professor of my university, Gitam, Hyderabad. So first of all, I am going to talk about bottleneck and intermediate node. What do you mean by bottleneck intermediate node? As you can see the diagram here, the point 2 is termed as bottleneck intermediate node. First of all, let us consider a live example like the water bottle. Consider any water bottle. The whole water from the bottle is taken away from the tip of the bottle node. So I mean bottle neck of the bottle. So here also we will compare the same. Here at the point 2, the whole data transmission is taken from 0, 5, 6. Consider all other nodes. It is all connected to the number 2. So that's why it is considered as bottleneck intermediate node. We can also term as 3 as bottleneck intermediate node, but not for all, as only the upper limits 0, 5, 6, 7 only are coming, but not the 2, 1, 4 things. Like 17, 18, 19 things. So here 2 is considered as bottleneck intermediate node. In this communication network, so in this communication network, maybe a single point through which all traffic must be flow. That is termed as bottleneck intermediate node. In MANET, bottleneck situation is related to network layer. In network layer, it is taken place. We have two kinds of processes that from which we can from which we can the flow of the data take place. That is traditional choice of route selection. Traditional choice of route selection means we manually select the routes through our path. Consider a three-way path is there. We manually select the best path, like displacement of the path. Maximum we will select the displacement. As displacements will take place, the path will be reduced and the cost will be reduced. And resource reservation for routing. Resource reservation for routing means on our organization, a router or something, an object which is already allocated, like the towers, Airtel towers, or any tower which has already enrolled its own resources to share the routes. For here the two can be taken by traditional choice of router selection or by resource reservation and resource reservation for router. And the next slide is, so first of all, from the source to destination interface is taken place, and output at the end output interface is done, and in between that input buffers are put for selection of packets, considering and saving it. We can have this we can check the performance of the bottleneck and magnet by using three ways, and the diagrams are here. Buffer overflow. Why we are saying while consideration of packet sharing from source to destination, there are many intrusion detection problems, and and many authors have not discussed that intrusion detection topic. So we came here to give the problems that are awaked by us while intrusion detection. So buffer overflow, like in this diagram, for example, considering the source 1, source 2, source 3 are sending the packets from source to destination 1, 2, or 3. But at the point of 4, where all other sources are sending their packets to the 4, the fourth source is overloaded, and due to overloaded, the packets have been dropped. This is one kind of problem. And the second kind of problem is similar to the first figure, figure number 3, limited energy. If a destination or a host have some limited energy to send data from here to there, due to when a source getting more number of incoming packets is for energy, if it is not energy efficient, it will drop some packets. And the third reason is line of connect. Line of connect means sometimes the path will be missing, sometimes the packet will be dropped itself, like a sudden breakage of current, or a packet misconception, and many more. So these are the problems regarding this. And now I'm going to discuss what we do mean by intrusion. Most routing protocols establish routine managed based on the assumption that all nodes are present and they are cooperating. For example, considering the path 1 to 10, 2, 3, 4, 5, 6 are the we are thinking that 2, 3, 4, 5, 6, 7, 8, 9 are the cooperative paths. But the problems behave by the 2 to 9th range are like, if the resources are less, they will drop the packet. If sometimes some resources refuse to forward the packet, that may be the problem, and this is known as intrusion. The main topic here we are going to discuss. And the packet drops by nodes in manage is a significant problem, as the packet delivery doesn't take place and create congestion, means clumsy type of nature and the wastage of the resources. And how can we find our intrusion detection systems? There are many intrusion detection systems IDs which are prepared for considering the intrusion detection. So credit-based approach. Credit-based approach means, for example, considering 1, 2, 3. If 1 is sending packet to 2, and through 2 it will send to the 3, while 3 is sending back, it always give an acknowledgement with a credit. That is known as, if the credit is came back to the source, then it will known as credit-based approach. Reputation-based approach and acknowledgement-based approach are the two other kind of thing. But out of 3, we have chosen acknowledgement-based approach more promising, and it depends on reputation of acknowledgement packet. As an acknowledgement, when the destination gives back is acknowledgement, we can make sure that the packet is reached. The packet is reached to the destination, and we can say that there is no intrusion detection takes place. So one of my co-author means the differences, Shakul Chai et al. proposed enhanced adaptive acknowledgement to provide the reputation to the acknowledgement by authentication. By authentication refers to the there will be a password protected by the user and the destination, the source giver and the destination giver. The password will be shared by the source and the destination, but not in between the persons who are sharing our data. So next slide. Here is the graph. Evolution of performance behavior due to the presence of bottleneck. If we are not considering, the bottleneck, the date relay, the packet delivery fraction, if we are not the packet delivery fraction first, as we can see in the map, that at the starting the packet delivery means the delivery of packets per Mbps is high. Like consider here is 55 to the green and 100 to the purple. But if we does not consider the bottleneck intermediate, there will be a fluctuation. Like from the high, it will show a high range at the starting, but continuously when it will go at low intrusion due to intrusion problem, it will become low. And similarly, if we consider the packet losses, the previous graph was respect to the packet delivery fraction. Now we are discussing about the packet loss. As our data Mbps is increasing, the packet loss will be increases. As we can see here, at the starting end, the packet loss was around 5,000, but as the data rate increases, the packet loss has been increases. We have came here to research that the IDS has neglected the bottleneck problem in the manner. So we came to detect the packet dropping loss due to the collision and lack of transmission proper. Packet drop due to collision and lack of transmission overcome with the use of reliable MAC protocol. By use of reliable MAC protocol, we can only consider the packet net drop, but not the time management. So our main concern is to need to prevent packet drops due to constraint resources such as buffer space and energy. As I said that when a source has more number of incoming calls, the buffer space will be wasted and the energy will be wasted too. So all packet droppings may not drop due to malicious activity. Malicious activity due to MANET exists adding distant vector routing protocols. Okay. Next, at last, I want to conclude that data communication in MANET should be secure. One of the major concepts for data communication is routing. Main aim of routing protocol is to select the path between the communication entity and the forward the packet through. Misbehaving nodes are majority due to packet drops by bit, but the packet drop may be caused by constant resources. Thus, in the network, we propose a mechanism to mitigate packet drop due to malicious activities as well as constant resources. Proposed work to not only mitigates misbehaving nodes, but also increases network performance in comparison with the existing algorithms. So at last, I want to give a further students to give a future work efficient mobile sync location placement in wireless network to overcome the problem of bottlenecks. We can overcome this problem by using the mobile sync locations. And thank you for listening my presentation. And these are the reference from whom I have got encouraged to give this presentation. Thank you, ma'am, for this opportunity. And hope do any people have questions? Hello.
Do anyone want to ask question? Okay, thank you, Nikhil. It was a nice presentation.
Thank you. you, ma'am.
Okay. So I will now invite our next presenter,
Thank you, ma'am.
Cuong, Dr. Hong Cuong. I'll invite our next presenter, Hong Cuong.
Okay, thank you.
Yeah, hi.
Hi. And I would like to say my work. Okay, to say my work. Okay. Can you see me? Can you see it?
Yeah, I can see and you are audible also, no problem.
Okay, and I presentation as follow. And I would like to present the work of a sliding mode control based output feedback additive dynamic programming for with inverted pendulum. As we know, the structure of an inverted pendulum has been described, has been shown in the slide. Okay, with the thin angle and direction angle and position, and we have to find the controller for this system to guarantee the checking of the position and the balance and the balancing of this device. As we know, the control method to implement this device, this inverted pendulum can be used nonlinear controller or optimal controller, and this work this work is to combine these two nonlinear controller. Okay, combine these two nonlinear controller based on the framework of nonlinear controller scheme and optimal controller. Okay, and to overcome the obstacle of disturbance and uncertainty, and the control objective is complicated. The optimal control is based on the classical HCB or LQR equation or Riccati equation. The HCB equation is described in the nonlinear system, and the Riccati equation is found in the linear equation, and extend this work to we obtain the adaptive reinforcement learning, and the parameter and variable of inverted pendulum can be illustrated in this slide, and we only care about the situation of balancing mode, balancing situation. Okay, the adaptive dynamic programming can be described in the Kleiman in 1968, and next step we consider the process of this control system. Okay, this closed system can be converged to the sliding surface infinite time, and the optimal control is actually described is actually described in the sliding manifold in the sliding surface. Okay, and we can obtain this work based on the Lyapunov stability theory, and we obtain the finite time conversion. Okay. The online on policy iterative can be shown in the algorithm 1, and with the step as follow. The step 1 is selecting the K0, the matrix K0, and we continue to update the next matrix. Okay, and this work has been described in in the in two case into methods including such as integer reinforcement learning based on the integer, and the second method is based on the Hamilton equation, and we can use optimal control to obtain the Hamilton equation being zero based on the least square based on the minimizations of the cost function. Okay, and next step we obtain the applied simulation as follow. Okay, and we can see the convergence of this algorithm and the checking problem of the wheel inverted pendulum. Thank you. Thank you. That's enough. Okay. Thank you. Thank you. That's enough. Okay. Thank you. Thank you. That's enough. Can you hear me? Can you hear me?
Okay.
Can you hear me? Okay.
Okay.
Now I wait for the question. I'm waiting for the question. I'm waiting the question for you. For me. I'm waiting the question for me. Oh, that's enough.
Mất cái nối rồi, trả lời hình ở trên.
Mất cái nối rồi. Thôi thế coi như hoàn thành nhiệm vụ nhỉ. Đấy, stop sharing rồi.
Vâng, tôi stop.
Thôi, quay trở lại. Ok, qua. I have just finished my presentation.
Thank you, Nguyen, for such a nice presentation. Am I audible? Am I audible?
Huh? Thank you. That's enough. Okay.
Can you hear me?
Yeah.
Cuong.
Cuong.
Yes. Me?
Yes. Yes, I hear you. And
I thank you.